Hello, everyone. Hello. All of y'all who all are there in this video, who all are watching this video, welcome to Letstute. And if you haven't subscribed to our channel, then do subscribe. And to all the CBSE students present over here, welcome. Welcome to this course in Letstute, where we are trying to cover a lot of concepts. One concept out of that we are going to cover today is friction. So friction is a physics topic. I am a physics teacher. My name is Sanjana Das, and I'm going to cover the concept. Now, before covering the concept, there are some basics that you should know. I have already covered the force and pressure chapter, which was once again a physics topic. So, the physics topic, force and pressure, is over. And today we are going to do the second topic related to force and pressure, but a little more complicated and a little more interesting. That is friction. So, in friction, the concept that you should know is that what do you mean by friction. You should also know what do you mean by what are the factors affecting friction. Then you should also know what are the different types of friction. So these are some of the basic concepts that you should know. So what is friction, what are the different factors affecting friction, and what are the different types. So the factors affecting friction, what are the types of friction? So these are the three topics that I'm going to cover today. First, what is friction? Second, what are the different factors affecting friction? And and third, what are the different types of friction? So who all have any doubt, you all can put it in the chat box. I'm going to cover it for you. Okay. So let's start with, let me just share the screen with you all. Yeah, here it is. Here is the chapter. The name of the chapter is friction. Now, before starting with friction, what do you mean by friction and why is friction so important? What if today I get up and tell you, let's not have friction? What happens if there is no friction? So, if there is no friction, I am not kidding. If there's no friction, you wouldn't be able to walk. If there is no friction, you wouldn't be able to stand. So, you are able to stand, you are able to walk because of friction. So, if there was no friction, then there is a chance that you may fall down. In fact, that's what happens when you stamp on a banana slip. When you're stamping on a banana peel, what happens is that the friction between the ground and you is completely gone. And because the friction is completely gone, what happens is because of no friction, the person can slip. So that is the concept about friction. Now, what do you mean by friction? So let me just quickly tell you the textual definition of friction. What do you mean by friction? So friction is a force that comes into play when two surfaces come in contact with each other. So let's take this example. If you're taking a book and when you're pushing that book, so when you push that book, the book's surface and the table, they both come in contact. When both of them are coming in contact, what happens is when both of them are in contact, the book and the table, the surfaces come in contact. When the surfaces are coming in contact, what happens is there's friction. So once again, let me revise. Friction is a force that comes into play when two surfaces come in contact with each other. So if there are two surfaces and they come in contact with each other, we say that there is friction. Now, next thing that you should know in friction is that what is the direction of friction. So let's understand it here. Okay, so if you're able to see it, you'll understand the direction of friction. So here we've understood what is friction. So if you apply force along left, the friction acts along right. Now, what does this mean? There is an experiment given here where they are trying to apply force on the book. So first time they are trying to apply force from the left hand side. They understand, or when you're pushing a book, you understand that there is a force which is acting in the opposite direction. So if you are pushing the book from left, the frictional force acts from right, and vice versa. If you are pushing the book from right, the frictional force acts from left. So this means that the force of friction is opposite in direction. Once again, the force of friction is opposite in direction. Why do we say it's opposite in direction? Because whatever the force is, whatever direction you are applying the force, friction is exactly in the opposite direction. So you saw that if you apply the force along left, friction acts along right. If you apply the force along right, the friction acts along left. In both the cases, the force opposes the motion of the book. The force of friction always opposes the applied force. So if you are writing it in an exam, remember you have to write this point where you explain that friction is always in the opposite direction. So if you're trying to apply force in a forward direction, friction is going to act backward. Now remember what we did. I'm going to revise. First of all, what is friction? So friction is a force that comes into play when two surfaces are in contact. So write down point number one. Friction is a force which comes in play when two surfaces are in contact. Then if someone questions you, okay, so now you define what is friction, now define what would be the direction of the frictional force. The direction of the frictional force would be in the opposite direction. So if friction is getting applied in the left, if a force is getting applied from left, the friction would be applied from right. Whatever it is, let's say if there is a ball moving. Now, if you have a ball moving, remember, and if there's a ball moving, the friction will always try to oppose. Friction will off. Hi, Mohammed, how are you? Mohammed, I'm sorry I didn't see you. Yeah, so I am sort of covering a topic called as friction. So, yeah, if you have any doubt, you can write it in the chat box. Whatever doubt related to physics you have, you can put it in the chat box. Now, so we were talking about friction, and we were talking about what is friction, what is the direction of friction, and a very simple concept: what happens if friction is applied on a body which is moving. So, point number one, if there is friction, okay, friction is an opposing force, and friction acts when two bodies are in contact. Second thing that you should know is that friction always acts in the opposite direction. So if you're applying something from left, friction will act from right. The next concept that you should know is that friction always acts on a moving body and tries to bring it at rest. So if there is a book, if you notice the book here, the book in this book is moving. Now, when the book is moving, if you see in figure 12.2, in figure 12.2 A and B, you'll notice that the book is moving. But when the book moves, okay, when the book moves, what happens is the friction tries to keep the book at rest. The friction tries to oppose the force, or friction tries to oppose the movement. So, point number one, you have to know that friction acts when two surfaces are in contact. Friction is a opposing force, it acts in the opposite direction, and friction opposes the motion between two objects. So if there are two objects, friction opposes relative motion. See, it's given there. Friction will oppose relative motion. So if something is moving, friction will try to bring it at rest. Now, after that, here comes another important question. What are the factors affecting friction? So, the force of friction acts between surfaces. We figured that out. Friction acts in the opposite direction. Now, what are the factors affecting friction? Whoever is watching this video, remember it is an important question that comes in your exam where they try to ask you what are the factors affecting friction. And it's a very common question. In the book, there are very less questions that can be asked. So, one out of that is the factors affecting friction. The factor is pretty interesting. So, please go through. If anyone is watching the video, if anyone is watching the video, remember it is an important question. What are the factors affecting friction? Now, for the factors affecting friction, let me just, yeah. So here's an activity. What they do is they're going to tie a brick. And after tying a brick, they connect a spring balance. Now, first of all, what is a spring balance? Anyone who's never heard about a spring balance is a device measured for weight. If you want to measure the weight of an object, you take a spring balance. So if you see in this spring balance, let me just zoom it in for you. Yeah, this is a spring balance. So in this spring balance, there is a hook, there is a holder, and there is a graduated scale. So what happens if we are applying a force, or if we are applying, or if we are putting a weight of 5 grams? So this is going to move, this pointer is going to move by 5 grams. If I pull a weight of 70 grams, so this pointer is going to move till 70 gram. So this is a spring balance which tells you the amount of force applied on it. So if you are applying force on the hook, the spring balance will tell you how much force you are applying. So spring balance is a device used for measuring the force acting on an object. Please mark it, guys, because it can come in your exam. So spring balance is a device used for measuring the force acting on an object. It consists of a coiled spring which gets stretched when force is applied. Stretching of the spring is measured by a pointer moving on the graduated scale. The reading on the scale gives the magnitude of the force. So if you see a spring balance and if I'm pulling the hook, so when I pull the hook, what happens is the pointer moves. So if I want the point, if I apply more force, the pointer moves more. If I'm applying less force, the pointer moves less. So the spring balance, this is an important concept of spring balance. So a spring balance is a device which tells you how much force is applied. So if a lot of force is applied, then the spring balance will show a lot of reading. Now, this spring balance is used to explain factors affecting friction. Now, for the factors affecting friction, if you see there's a experiment where there's a brick and there is a thread attached to it and a spring balance. So, when the spring balance is pulled based on the weight of the brick, if you notice, based on the weight of the brick, the spring balance will show a reading. Now, first of all, who causes friction? If someone questions you, who causes friction? So, if you notice carefully this part, look at the surface. Look at the surface of the table. So, if you see a table, the table appears very, hi Mohammed, whoever this is, hello. So, if you look at the table appears to be very smooth. But the moment, though the table appears smooth, the moment you magnify it, you will notice that the table actually consists of a lot of irregularities. Same goes for the book. The book, which appears to be very flat, also consists of these irregularities. We call them ridges and grooves. Once again, a surface may look flat, but sometimes it is not flat. It consists of a lot of irregularities. Now, due to these irregularities, now this is a very important concept. What happens is, let me just explain it to you here. Now, due to these irregularities, let's see, there's a table and there's a book. Now, the table which is kept and the book which is kept both have irregularities. So now, when I'm trying to move the book above a table, what happens is these irregularities and the book's irregularities, they sort of meet and they fix to the grooves and ridges. Now, when this is happening, when I'm trying to take the book forward, what happens is these small grooves and ridges try to hold it. They try to hold the book. Now, when they're trying to hold the book, what happens is there is a you can say opposite force acting on the book. So that is friction. If someone questions you what is friction, remember surfaces are not completely plain. Surfaces are rough. Now when the surfaces are rough, when the surfaces are rough, what happens is sometimes while moving, the grooves and ridges themselves. So if you see the table's grooves and ridges and the book's grooves and ridges, they will attach themselves. Now, when this happens and when I try to move the book, I'm not talking about picking the book. What happens if I push the book? So, when I'm pushing the book, due to these grooves and ridges, it is difficult to push it. So, we say the friction is very high. So, this is friction. Just go through this. This is friction. If someone questions you, what's the prime reason? What's the important reason? Why does friction take place? So, friction takes place because the surfaces are not plain. The surfaces have a lot of grooves and ridges, and these grooves and ridges combine with each other and form. Once they are combined to each other, they are sort of very rigid to move. They don't move. Thus, you have to apply more force, and that is called as friction. So, friction, if someone questions you, why does friction occur? You all can write it. Friction occurs if the surfaces are irregular. If the surfaces are irregular, then friction occurs. Now, if you move an object which has an irregular or rough surface on another surface which is also irregular, the force of friction will be high in these kind of cases. And thus the object moving would be slow. In that place, so here if you notice the book and the book, though we think that they're very smooth, but they are rough. So what happens is the book sort of, the particles attach themselves here. So when the particles attach themselves here, it is very difficult to move. So yeah, grooves and ridges are the reason for friction. Now, the factors affecting friction. There are some basic factors that everyone should know that affects friction. First was the irregularity. So the smoother the surface, the less would be the friction. So if a surface has like a lot of friction, then it's not smooth. So if the surface of either the object or the surface are smooth, the force of friction would be less and the object would move easily over the surface. Even smooth surfaces have a certain irregularity. Now, what does this mean? This means that surfaces have. So if you notice the surfaces, they have different ways of like applying friction. If the surface is very, very, very uneven, then the friction is very high. But if the surface is very clean and very like smooth, so then the friction is very less. If also let's go through the textbook and see what they have given. So here the surface ka concept is there. So here there are two boys. What they are doing is they are trying to put a battery at a certain height. From a certain height, they are trying to throw it. Now, when they do that, what happens is if they're doing it in a smooth table, the battery goes to a certain extent. But when they do the same thing with a cloth below, then it goes only halfway. For a sole reason that the cloth sort of increases the friction. Because the cloth increases the friction, it's sort of like proved that friction is like a contact thing. It depends on contact, and if the surface is smooth, then the friction would be very less. Now, so one reason was the surface. The second reason is okay. So one reason for increase in friction is the uh, you can say the surface. Greater the, you can say, friction, greater the irregularities, more would be the friction. So does the distance, wait, let's just go through this. In fact, even this one more factor affecting this was friction was that uh, whatever the weight is, like a brick is being pulled by a spring balance. So in friction, like when you're pulling it and all, it will sort of increase the weight. Like if you're directly putting it on a cross in a like a proper weight, then it will weigh something. But when you're moving it, okay, when you're moving it, what happens is the friction increases. So I've explained you this. Okay, let me just explain this. Does the distance covered depend on the nature of the surface on which the cell moves? Yes, it does. Because if you take the second case where you had put a cloth, you had increased the friction, because of which the distance traveled by the batteries or the cell, the distance traveled by the cell also decreased. So, if you go through this concept, they've said friction is caused by the irregularities on the two surfaces in contact. Even those surfaces which appear very smooth have a large number of minute irregularities on them. Irregularities are on the two surfaces lock into one another. When we attempt to move any surface, we have to apply a force to overcome interlocking. On rough surface, there are large number of irregularities, so the force of friction is greater if a rough surface is involved. So common sense, what happens when a rough surface involves is uh, there's no liquid to decrease the thing. Hi, whoever's watching this, I am teaching a topic in friction. We have come to the factors affecting friction. The first factor affecting friction. Hello, Rajesh. So, Rajesh, we were doing a topic called as friction. I am like almost 6 minutes are remaining to finish the topic. In friction, I have explained what do you mean by friction, and now I am explaining the different factors affecting friction. So, out of the factors affecting friction, one out of that is the surface. The surface is very irregular, and then like it will look smooth, but it is not. And yeah, the like also one more thing is how does friction look like and all. So those all are the things that is there. uh, Now if you see carefully, I have explained friction ka definition. Friction is caused by the irregularities. Even smooth surfaces undergo friction. Remember one thing, Rajesh, that friction can never be zero. Scientists are trying, but always there would be some amount which would be left. Thoda, very less friction at least, but it would be there. So friction is, you can say that friction, it keeps on increasing. It will keep on increasing. Now, in factors affecting friction, I told you. Okay. So friction a necessary evil. Now, why do we say that friction is a necessary evil? I'm not going to explain that. I'm just going to explain you what are the different types of friction so that it helps you. The rest of the topics I'm going to teach you next time. Today, I'm just going to teach you what are the factors affecting friction, and what are the different types of friction. So first you can say factors affecting friction. The biggest thing, please write it down, is the contact surfaces. If the contact surfaces are very rough, think of sandpaper. When you're rubbing it, it's so rough, the friction is so high. So based on the type of surface, the friction is sort of like, yeah. So the friction is sort of decided. So if the surface is very smooth, the friction is very less, and if the surface is very rough, then this friction is also very high. So factors affecting friction. If you notice this, okay, this is done. Okay, all of it is done. Like we've explained the grooves and ridges. We've explained yeah, so all of those concepts. For factors, why is it that some surfaces are more, you have to apply more force to push objects in those surfaces, for a sole reason that the surface has a lot of friction. Now, hi Archie, how are you? So yeah, so okay, Rajesh is here, Archie is here. Okay, so now let's go to the last concept. The last concept is the different types of friction. Now, for the different types of friction, uh, if you notice here, it will sort of help you to understand what are the different types of friction. So, one out of that is static friction. Static friction is when an object starts moving. So when an object starts moving, for example, if you're playing carom and when you're up hitting the striker, what happens is the striker, which was initially at rest, starts moving. So when the striker starts moving, what happens is static friction is acting upon it. Then another is sliding friction. Sliding friction is when an object moves along the surface of another object. So, if there is like a object at rest and when you hit it, the object starts moving. So, initially, the force that is applied is static friction. But now, when the object is moving or when it is sliding above another contact surface, because it's sliding, there is some amount of friction that is added, that is called as sliding friction. Now, if you take a tire, the tire doesn't slide, the tire rolls. So the friction where objects roll, and when they are rolling, they apply some amount of, they get some amount of friction. That rolling is called as rolling friction. So when objects roll, there is some amount of friction in it, called as rolling friction. Last is fluid friction, which does not happen in air, but if you are going through water, try moving in a swimming pool. Try walking through a swimming pool. So when you're trying to walk through a swimming pool, you'll understand when you're walking through a swimming pool, it's very difficult for you to walk. The reason it's very difficult for you to walk is because of a concept called as fluid friction. So today we understood a lot of concepts. Let me just give you a quick recap. You understood what is friction. Friction is a force which acts when the surfaces are in contact. Okay. Also, what would be the direction of force? So the direction would be in the opposite direction. If someone questions you that what if I'm applying a force from left? Where would the friction act? Remember, if you're applying a force from left, the friction would apply in the right. Now, after that, after understanding friction, after understanding the factors affecting friction, remember the surfaces are not completely smooth, they are rough. Even the object that you're placing, even that is rough. So, because of which, what happens is they try to connect. There are grooves and ridges formed that try to connect. Now, when they are trying to connect, what happens is, and when you're moving it, initially there is static friction. Due to static friction, what happens is you experience a force. Now when you're moving it, or when it is rolling, sorry, when it is sliding above the surfaces also have grooves and ridges. So now they may not fit, but they may come in contact. Now when they are coming in contact, um, you can say that it is the friction has increased. Then we understood the different after factors affecting friction. Then we understood the different types of friction, like rolling friction, sliding friction, rolling friction, sliding friction, then static friction. So all of these things. Then comes fluid friction. So all of these things are sort of related to friction. So for today, I'm going to end the lecture. Next lecture, I'm going to complete this chapter of friction. Okay. So bye. Bye, guys. Have a nice day.